In question number 3, it's going to ask us to make some comparisons from this graph that they gave us on the page to the graph that we see in question number 2. In number 3, letter A, it asks you to look closely at what makes this graph different. Now, obviously, the scale of the graph might look a little bit different. This graph looks a little bit taller, so I don't want to nitpick those sorts of details because it might just be that there's a small difference in the actual physical size of the diagrams, and that's not really something that we should worry about. But more specifically, let's see if we can really dig deeper into the patterns here, because it looks like I have a wave in question number 2. It looks like I have a wave in question number 3. There's got to be something deeper than that. There's got to be something else to look at. Oftentimes when you're looking at a wave graph, it can be really hard to look at any specific spot because it's not like a parabola where there's an obvious vertex or something. So what I'm going to do in the graph for question number 2 is highlight to myself a little reference point. I'm just going to use 0, 0 as a reference point just because it's kind of a natural starting point. We usually use 0, 0. So I'm going to highlight that as a reference point. And now it gives me something to kind of notice. For example, if I'm at 0, 0, going towards the right, the graph appears to head upwards, and then down, and then into the bottom half, and then back to 0 again. So I'm just kind of noticing the general behavior of this shape. Now, if I go to 0, 0 on this next graph in question number 3, I immediately notice a difference. This must be the difference that they were asking about in the question. Because if I look at 0, 0 now, from 0, 0, this graph heads downwards in order to get to the next point on the graph. And the original graph in number 2 headed upwards. So that immediately is a difference that I want to make sure that I specify. This graph is different because from 0, 0, it heads down, not up. Again, if you want to pause, so that way you have some time to write that into space, go ahead and pause the video so that you can put this into your own words. Once you feel like you understand what makes this graph different, let's see if we can connect it to our Ferris wheel analogy. It says in letter B to explain what would be different about the Ferris wheel on this graph. If this graph represents a Ferris wheel that starts at 0 but heads downwards, then we have to imagine that this Ferris wheel would start at 0, our starting point, but it would work in reverse. So this Ferris wheel must rotate backwards compared to a normal Ferris wheel. And if you want to think of it in those terms, you can. If you want to put those in better words that make more sense to you, that's fine. But now I know this diagram must represent a Ferris wheel that rotates backwards because it starts out and heads underground first, as opposed to the first one that starts out and heads above ground first. Now, this is where we should think a little bit logically about the graph. If you think about it, this graph in question number 3 is almost the exact same graph as the one in question number 2. It just looks like it's been flipped. It looks like it's been reversed. In other words, if I try to draw lightly, it kind of just looks like, if you can make out that very faint little dotted line that I'm drawing here, it almost looks like the graph originally has just been reflected. And if you think about that in the context of graphs we've already seen, that might remind you of things like parabolas, when we flip them in order to change the way they're facing. If this graph is basically just facing down compared to the graph in question number 2, we can say the graph in number 3 has basically just been flipped upside down. Now this is where it might be helpful again to think about the equation. If the equation of the original graph is sine, or sine x, and the new one is just the flipped version of that, think about what normally makes things flip. Usually to flip a parabola, for example, we put a negative in the front of its equation. So this is going to work the same way. If I need to flip this graph, I'm going to put a negative in front of its equation. So the equation for this new one is going to be y equals negative sine x. You don't have to put the parentheses around the x. Some people do, some people don't. So you'll notice I'm purposely writing it 2 different ways here so you can see that both ways are acceptable. Now, in case you're not really convinced that that actually worked, in case you're not actually convinced that this is going to make sense, let me just quickly show you on a proper graphing calculator that what we did is actually completely correct. If I type sine x as my equation, and if I change my window to ensure that I can see everything I need to, so this graph, for example, went all the way to 4 pi, and I'm just changing a couple of settings so that way you can see it clearly. This was the original graph from question number 2. And if you look at it, you can definitely tell it's pretty accurate. There's my 0, 0, and it's going up and then back and then down and then back and then up and then back and then down and then back. If I wanted to see the little left-hand side just so it makes a perfect match, I can actually extend it just a little bit. Now it's a perfect match. So this again was the graph for question number 2. Now we hypothesized that the graph in question number 3 has the exact same equation, just negative. So if I go back to my grapher, and if I type negative sine x, which now should graph in a different color, let's take a look. Sure enough, this new red graph does look exactly like what we just saw. If you're having a hard time seeing it, I can turn off the first one just so that way it's not so confusing. There, sure enough, is exactly what I expected to see from graph number 3. It starts at 0, 0, it heads downwards, and the entire pattern totally matches. If you have a graphing calculator or access to Desmos from home, then you can definitely graph these as you go and check them if you want to. In question number 4, we're given yet another comparison. So before we take too much time to convolute things, take a moment to digest everything that just happened in question number 3. Make sure that we understand the difference between the main graph that we were dealing with in question number 2, which by default starts from 0, 0 and goes up, and then make sure you understand the difference in this graph number 3, where it starts from 0, 0 and goes down. The negative controls the going down part, and that connection is super important. In the next video, when we discuss question number 4, I want to make sure that we still have that main idea in mind, that we're constantly going back and comparing it to the graph from number 2. So between now and the next video, just digest that information, make sure that you've got the idea, and in the next video, we'll do another comparison.